Hello learners, welcome to Chemistry Nuggets. I am Akanksha and today's topic is Ionic radius of isoelectronic species from the chapter Periodic Classification. So let's get started. From this chapter, most commonly asked question is, consider the following species like nitrogen 3-, oxygen 2-, fluorine 1-, sodium plus, magnesium 2+, and aluminium 3+. Now, first question is, what is common in them? And the second question is, arrange them in the increasing ionic radii. So, first of all, we will go to the first question and we will see what is common in it. See it carefully. Nitrogen 3-, oxygen 2-, fluoride 1-, sodium +1, magnesium +2, and aluminium +3. Is there anything common? No. From the beginning, if we say, looking from here, nothing is common. Everything is different. But I will tell you what is common. If we take the nitrogen 3-, now oxygen 2-, then fluorine, minus means 1-, then sodium +1, magnesium 2+, and aluminium 3+. If we write the number of electrons in each cases, then we will have some hint what is common in them. So as we know, in the atomic form, nitrogen has, we can write it here, atoms form में nitrogen has how many electrons? 7. Oxygen has 8 electrons, fluorine has 9, sodium has 11, magnesium has 12, and aluminium has 13 electrons. When in the atomic case, when there is a nitrogen atom, it has 7 electrons. We can say oxygen atom 8 electrons. So, but here these species are in the ionic form. As we can see, plus charge, minus charge are there. So it means they are in ionic form. So in ions, number of electrons will be in n-3. So in normal case it has 7. So 7 minus 3 means 3 electrons added. So what will the number of electrons now? 7 plus 3, 10 in case of nitrogen. In case of oxygen, 2- means 2 electrons added to the atom to become an ion. So 8 plus 2, 10 again here. In case of fluorine, 1- means 9 plus 1, 10. Now in case of sodium plus 1 means 1 electron is removed from the sodium atom. So sodium atom has 11 electrons, and if we remove 1 electron, it will become 10 electrons and it will become sodium atom. Sodium ion. Now next, magnesium 2+ means 2 electrons less. So 12 minus 2, 10. Aluminium 3+ means 3 electrons less from aluminium. So it will become 10 electrons, 13 minus 3. Now see carefully. In the ionic form, all the species is given here having 10 electrons, 10, 10, 10, we can see. So now, we can answer the first question. What is the first question? What is common in them? We can see the common thing, number of electrons. So we can answer the first question that the common thing in all these given species are the number of electrons. All the species is having same number of electrons, that is 10. So these are called isoelectronic species. Understand? These are called isoelectronic species. Now the second question, this first question is done. It was very easy, we can see. Second question is, arrange them in the increasing ionic radii. Now we need to talk about ionic radii of the isoelectronic species. For that we have some rules. As we can see, we have here two groups, one of anions and the other group of cations. So in both the cases we have separate rule. First rule we are going to take is for cations. For cations means, first we write the cations over here. Cations are sodium plus and magnesium 2 plus, and the third one is aluminium 3 plus. These are the cations. For cations, greater the charge, smaller the radii. Which is greater in charge? 3 is greater than magnesium. Magnesium ion is greater than sodium ion. So, greater charge, smaller radii. We can say like this. Greater charge, smaller radii. इन दोनों में कंपेयर किया. When we compare this and this is greater charge, so smaller radii. Smaller charge, greater radii. In the same way, here also, greater charge, smaller radii. Smaller charge, greater radii. Understand? This is according to the rule, but let's see why this rule is here. So, if we draw the octet structure, let's see, already we know how to draw. This is nucleus in the center. Then how many electrons it has? 10. We knew that in isoelectronic species is 10 electrons. Only once I will draw, then I will explain you. See, 10 electrons. So in case of sodium, electrons 10 and the protons will be, which is in the center. How much proton? The proton will be 11. Now the question, why? Because when the ions are formed from the parent, only the number of electrons will be changed. There is no change in the number of protons which is sitting in the nucleus. So parent atom having 11 electrons in case of sodium. So in case of sodium ion, the number of proton will be 11. Same in case of magnesium also. Number of electrons, I will draw once. Nucleus, then first and then second. See, 2 and 8. Because number of electrons are same as these are the isoelectronic species. Now, electrons 10 and protons will be 12 as magnesium having 12 electrons. And in case of aluminium, sorry, why should I write aluminium over here? We need to draw the octets of aluminium 3 plus. It will be center, then outermost second and the outermost shell, because only 2 shells are there. The electrons again 10 and protons are 13. Okay? In case of sodium, in case of magnesium and in case of aluminium ions. Now let's see the distance from the nucleus. In all the 3 cases are same up to the second shell only. In all the 3 cases the distance is second shell from the nucleus, means distance is same, but the positive charge which is sitting in the center and which is exerting the force of attraction on the outermost shell, in this case the second shell, is different. Positive charge is different in all the 3 cases. Here 11, here 12, here 13. So we knew that more the positive charge, smaller the size. As we can say, size or radius is inversely proportional to the number of protons. As the proton increases, size will be smaller. Understand? So proton here is more, so size will be smaller from the previous one. If we compare magnesium ion and aluminum ion, here the proton is less, so size will be more. Proton less, size more. Here also same case. In case of sodium ion and magnesium ion, number of proton less, size more. So this size is bigger than this, and this size is bigger than this. Understand the concept? Now, this is for the case of cations. Now, let's jump to the anions and see what is going on there. Now, the second rule for anions are, for anions, greater the charge, larger the radius. So, first we write the anions over here. First anion we have is N-3. The second will be O-2, and the third will be F- or -1, we can say. Minus means -1. So, anions greater charge. Which is greater? This one is greater, having 3 charge, 3 minus charge. This is the great charge. See, greater charge, larger radius. Great charge, large radius means large size. If we compare this two, and in this two, this great charge, see, 2 charge, great charge comparison to the F, which have 1 charge. So great charge, great size or large size, we can say, according to the given rule. Let's explain this again. Again we can draw the octet structure, or just simply let's see what is going on here. Now we knew number of electrons in this case is, in case of nitrogen ion, 10, or number of protons will be 7, that is plus charge. In case of oxygen, number of electrons 10, number of protons will be 8, because in the parent number of protons are 8. In case of fluoride ion, number of electrons 10 and number of protons will be 9. Now see again, as I told, larger the protons, more the protons, smaller the size. Now see here, more the proton, here proton in case of fluoride ion, number of proton is 9. So it is more, it means it has the smaller size than the oxygen, which is having 8 protons. So we can say like this, and again like this. See, so what the rule we put here? Again, size is inversely proportional to proton. As the proton less, size will be large. So proton is less, size will be very large. Proton, as the proton increase, size increase. As the proton increase, size is again decreasing. Size, proton increase, size decrease. Proton increase, size decrease. This rule is here what we are going to apply. Same we can explain with the octet structure. As we did earlier, if we draw octet structure, this is nucleus. For nitrogen, we have 10 electrons. Now, it has 7 plus for nitrogen, 2 over here and 8 over in the second. In this case, we have oxygen. If we make for oxygen, 8 plus charge in the center, and then 1, 2, 3, 4. Oh, what I'm going to do? Wait, this is wrong. Again I will draw. Sorry. First of all, nucleus with 8 plus, then first shell 2 electrons, and then second shell having 8 electrons, as it has only 10 electrons. Now see, this is for nitrogen, N3 minus, this is for O2 minus. More the positive charge in comparison to the nitrogen, here it is plus 7, here it is plus 8. The distance is same. If we understand like this also, distance is same. The force of attraction is more in case of oxygen ion. So more the power, more the attraction felt by the outermost shell, and it will come closer to the nucleus with more power. So the size of oxygen ion will be smaller in comparison to the nitrogen ion. So we can say this size will be, and this will be same as the rule says over here. Nitrogen is larger and oxygen is smaller. Same we can describe oxygen and fluoride ion. Either we can describe like this or we can describe like this. Both the explanations saying the same thing which is given in the rule. So I hope this is clear to you. Now, so we can say overall we need to arrange them in the increasing ionic radii. So one more thing I want to tell you. If we write, now we can get nitrogen 3 minus, oxygen 2 minus, fluoride minus, then sodium plus 1, magnesium 2 plus, and aluminium 3 plus. So I knew all are 10, 10, 10. The protons E is equal to 10 and P is equal to here 7, here 10 and 8, here 10 and 9, here 11, sorry, this is 10 and this is 11, here electrons 10, protons 12, here electrons 10 and proton 13. So we can consider it in one very simple line. The rule will be size is inversely proportional to E upon P. So more the proton, because E is 10 in all the cases, so E is not changing. So the what the change which is matter? Change of protons. The protons, more the protons, smaller the size. So now according to this rule we can arrange this all these things in a sequence. So here this is the smallest number of protons in case of nitrogen. The smallest number of protons or the force of attraction in case of nitrogen ion is very less, so the size will be very large. So nitrogen 3 minus is the largest, then comes oxygen 2 minus, then comes fluoride minus, then comes sodium plus, then magnesium 2 plus, and then aluminium 3 plus. So this is the arrange them in increasing order, ionic order. I gave you the decreasing order. This is the biggest and this is the smallest. Let me rub this and write in the proper way as the question asks. Increasing ionic order. So first of all we will write smallest one. Which will be the smallest one? According more the positive charge, the smallest is the size. So here the smallest one will be the aluminium 3 plus. After that, sorry, again wrong. Sorry. Then we can write like this. The bigger one is the magnesium 2 plus having 12 protons. Then will come sodium plus having 11 protons. Then will come fluoride, it having 9 protons. Then will come oxygen ion having 8 electrons, and the largest will be the nitrogen 3 minus ion having the 7 protons. So this is largest number of protons, the smallest is the size. Then increase, and this is the largest size. Understand the concept, understand the isoelectronic species, and understand the concept of how to arrange them. So hope you guys understand this video and concept how to arrange any of the given isoelectronic species according to their number of protons and electrons. As the electrons are same in the case of isoelectronic species, we need not to worry. Only the point we need to consider is number of protons. So hope you guys understand this concept, and if you have any doubt or queries, please feel free to write down in the comment section. Thank you.